In this video, we're going to talk about dilution problems and how to solve them. The equation that you need is this one. M1V1 is equal to M2V2. M stands for the molarity or the concentration, and V is the volume. Now, V could be in milliliters or liters, but it has to match. If V1 is in milliliters, V2 has to be in milliliters. If V1 is in liters, V2 has to be of the same unit. Now, let's say if we have a solution with a concentration of 2M, and let's say it's sodium chloride. How can we decrease the concentration of this solution? Let's say we have a volume of 200 milliliters. How can we decrease the concentration? If you want to decrease the concentration, you need to dilute the solution. You need to add water. If you add water to it, the solution will be less concentrated. So let's say if we add 200 milliliters of water so that the final volume is 400. If you double the volume, the concentration is going to be reduced by a factor of 2. So if you divide this by 2, it's going to be 1. So now you have a 1 molar sodium chloride solution. So keep that in mind. Anytime you need to decrease the concentration of a solution, simply increase the volume by adding water or whatever the solvent is. Now, what if we want to increase the concentration instead of decreasing it? How can we do so? One way in which you can increase the concentration is by adding more salt. If you add more sodium chloride, the concentration will go up. Another way is to remove H2O if you don't want to add solute. You can remove solvent. And one way to do so is by evaporation or vaporization. If you leave the beaker open in a dry room, water will naturally evaporate. And so in time, the volume will decrease. So let's say if you get the volume down to 100. If you decrease the volume, the concentration will increase. So now you'll have a 4 molar sodium chloride solution. So anytime you want to decrease the concentration, dilute it with the addition of water. If you want to increase the concentration, remove water by evaporation or add more solute to it. Now let's work on a few problems. Number 1, a 0.8 molar HCl solution, I forgot that word there, was diluted to a final volume of 500 milliliters. If the new concentration is 0.20, what was the original volume of the solution? So what can we do to figure this out? For a typical dilution problem, you can use this equation. M1V1 is equal to M2V2. Now, if M1 is the original concentration, V1 is the original volume, which makes M2 the new concentration of the solution, and V2 is the final volume. So the original concentration is 0.8. That's the concentration of the solution before any water was added to it. Our goal is to find the original volume of the solution. So we're looking for V1. We have the new concentration. It's 0.20. We also have the final volume. It's 500. So now let's find V1. The first thing we need to do is multiply 0.2 by 500. And that's equal to 100. Next, we need to divide both sides by 0.8. 100 divided by 0.8 is 125. So that's the original volume of the solution. Now let's make some sense of these numbers. The volume changed from 125 to 500. So therefore the volume increased by a factor of 4. In a dilution problem, anytime the volume increases, the concentration will decrease proportionally. The original concentration was 0.8. The new concentration is 0.2. So you have to divide that by 4. So if you divide the concentration by 4, the volume will increase will be multiplied by a factor of 4. So I want you to understand that concept. Now let's move on to part B. How much water was added to make this happen? So the volume changed from 125 to 500. To find out how much water was added, subtract V2 by V1. 500 minus 125 is 375. So 375 milliliters of water was added to the original solution to decrease the concentration from 0.8 to 0.2. Number 2. The concentration of a 300 milliliter aqueous KCl solution was increased from 0.25 to 0.75 molar by evaporation. What is the new volume of the solution? So let's use the same equation. M1V1 is equal to M2V2. Our goal is to find V2, the new volume of the solution. The original concentration, M1, is 0.25. The original volume is 300. And the new concentration is 0.75. Now let's think about this conceptually. The concentration was increased from 0.25 to 0.75. That means it was increased by a factor of 3. If you increase the concentration, the volume has to decrease. So if the original volume is 300, to find the new volume, conceptually, divide it by 3. So the new volume should be 100. But let's get that answer using the equation. 0.25 times 300 is 75. So let's divide both sides by 0.75. 75 divided by 0.75 is 100. So you'll get the same answer. So that's the new volume of the solution. Now, how much water was removed? So we went from 300 to 100. To find out how much water was removed, take the difference between V2 and V1. So V2 is 100, V1 is 300. So the change in volume is negative 200. The negative sign indicates that water was removed. 200 milliliters of water was taken out of the solution by evaporation. Number 3. 350 milliliters of water was added to 225 milliliters of a 4.5 molar sodium hydroxide solution. What is the new volume of the solution? So feel free to pause the video if you want to try this problem. So I'm going to use the same equation. M1V1 is equal to M2V2. So what's M1 in this problem? We're looking for the new concentration, so we're trying to find M2, which means M1 is the original concentration of 4.5. V1, what's a V1 in this problem? We're also looking for the new volume, by the way. The volume that corresponds to this solution is 225. Right now, we don't have the value for M2 or V2, so we can't find V2 using this equation. So we got to find V2 another way. What other way can we find V2? Let's make a list of what we have. We have V1, which is 225 milliliters. Now, the 350, what does that represent? And how can we use that to find V2? The 350 milliliters is the amount of water that's added. So basically, that's the change in volume. Since we increased the volume by 350, the change in volume is positive 350. If water was removed by evaporation, the change in volume will be negative. So we know that delta V, let me put this on the right side, is equal to V2 minus V1. So delta V is 350. We're looking for V2. V1 is 225. So basically, we got to add 225 to 350. And that will give us the new volume. So 350 plus 225, that's going to be 575. So that's V2. That's the new volume of the solution. If you started with 225 milliliters of solution and then you add 350 milliliters of water to it, then you should end up with 575 milliliters of solution. Now that we have V2, we could find M2. So it's 4.5 times 225, which is 1012.5. Next, let's divide both sides by 575. So M2 is 1012.5 divided by 575, and that comes out to be 1.761. So anytime you add water, the concentration will decrease. In our example, it decreased from 4.5 to 1.761. So that's the answer for part B. It's 1.761. The answer for part A is 575. Number 4. 60 milliliters of a 0.8 molar sodium chloride solution is mixed with 80 milliliters of a 0.5 molar KBr solution. Part A. What is the new concentration of sodium chloride? In the first 3 problems, we were adding or removing water, and that's it. But in this problem, we're mixing two different solutions with different substances in them. We have 2 different substances, NaCl and KBr. So how can we find a new concentration after mixing these 2 solutions? Well, first, we need to calculate the final volume of the combined mixture. And that final volume is going to be 60 milliliters from the NaCl solution plus 80 from the KBr solution. So V2, the final volume for both solutions, which is not one solution, is 140 milliliters. So let's use pictures to represent what's going on here. Let's say the first solution is NaCl and the second solution is KBr. The volume for the first one is 60 milliliters and for the second it's 80. And the concentration of sodium chloride is 0.8 and the concentration of KBr is 0.5. So once we mix the 2 solutions, the volume of the new solution is going to be 140. It's going to be 60 plus 80. What's going to happen to the concentrations of NaCl and KBr? Will they increase or will they decrease? For NaCl, the volume went up from 60 to 140, so it did more than double. So therefore, the concentration will decrease. Anytime the volume goes up, the concentration will go down. So since the volume increased more than a factor of 2, the concentration should decrease more than a factor of 2. So the final answer for NaCl should be less than 0.4. Now for KBr, the volume increased from 80 to 140. It didn't double. It increased less than a factor of 2. So the concentration should be reduced by less than a factor of 2. So the final concentration should be greater than 0.25, but less than 0.5. So let's start with the concentration of NaCl. So we're going to use the same formula, M1V1 equals M2V2, but with reference to NaCl. The original concentration is 0.8. The original volume is 60. We're looking for the new concentration of NaCl, and the new volume is 140. So M2 is going to be 0.8 times 60 divided by 140. So the new concentration of NaCl is 0.343. As you can see, is less than 0.4. Now let's do the same thing for KBr. Let's use the same formula. The original concentration of KBr is 0.5. The original volume is 80. The new volume is the combined solution, which is it has a volume of 140. So M2 is going to be 0.5 times 80 divided by 140. So the new concentration of KBr is 0.286 M. So it's greater than 0.25, but it's less than 0.5. So now you know how to find a new concentration of two solutions after they're mixed with each other. Now, what about this one? 150 milliliters of a 0.6 molar calcium chloride solution was mixed with 300 milliliters of another calcium chloride solution. What is the new concentration of the mixture? In the last example, we mix two solutions that contain different substances, and so the concentrations of both solutions decreased. In this example, we're mixing two solutions with the same substance. So the concentration of this solution, the second solution, will decrease, but the concentration of the first solution will increase. So what's going to happen is you're going to get a weighted average. Do you think the new concentration will be closer to 0.6 or closer to 0.9? What would you say? The midpoint of 0.6 and 0.9, if you add them up and divide by 2, is 0.75. Notice that we have a greater quantity of the more concentrated solution. We have twice as much more. Therefore, the new concentration is going to be somewhere between 0.75 and 0.9 because we have more of the concentrated solution. So basically, this problem is a weighted average problem. Now, we need to modify the equation a bit. It's going to be M1V1 plus M2V2, and that's equal to M3V3. So if you're looking for M3, the new concentration, it's going to be M1V1 plus M2V2 divided by V3. I want you to understand how this equation works and what it means. Whenever you multiply molarity by volume, it's going to give you moles. N is equal to CV, or MV. C and M are the same concentration. And you could use the units to help you figure this out. M, the molarity, is defined as the moles per liter. And if you multiply it by the volume with units of liters, this will give you the moles. So M1V1 is basically the moles of the first solution. M2V2 is the moles of the second solution. And V3 is the volume of basically the combined mixture. So N1 plus N2 is basically the total number of moles of calcium chloride. VT is the total volume. If you take the total moles and divide it by the total liters, you're going to get the new concentration of the solution, M3. So I want you to understand how this problem works. So if you found the moles of the first calcium chloride solution, and then add it to the moles of the second calcium chloride solution, and divide it by the total volume, you would get the same answer, M3. Or you could just use this equation. Just add an MV component to it. So let's say if we wanted to mix three solutions with the same substance, I would use the formula M1V1 plus M2V2 plus M3V3 is equal to M4V4, where V4 is the combined volume of everything. So you can keep adding MVs to these equations if you're adding a solution that contains the same substance. If not, then it doesn't work. Now let's finish this problem. M1 is 0.6. V1 is 150. Now for the second solution, M2 is 0.9 and V2 is 300. V3 is the sum of 150 and 300, which is 450. 0.6 times 150, that's 90. So right now this is not 90 moles, but 90 millimoles, because we're multiplying molarity by milliliters. If we multiplied molarity by liters, this would represent moles. So the first solution has 90 millimoles. The second solution, 0.9 times 300, contains 270 millimoles. And so this is equal to M3 times 450 milliliters. 90 plus 270, that's 360. So to find M3, it's going to be 360 divided by 450, which is 0.8. So that's the concentration of the combined mixture. As we said before, it's between 0.6 and 0.9, but it's closer to 0.9 because the midpoint between 0.6 and 0.9 we said is 0.75. And we mentioned that the answer should be somewhere between 0.75 and 0.9 because we have a greater quantity of the more concentrated solution. And so the average concentration is going to be closer to 0.9 since we have a greater volume of the concentrated solution. So hopefully that makes sense. Just remember, if you're mixing two solutions with the same substance, your final answer, the concentration, is a weighted average of these two values. If the volumes were equal, then the concentration will be exactly in the middle, will be 0.75. But if the volumes are unequal, the final concentration will be closer to the concentration that has a greater volume.